Today I'm going to be learning about energy harvesting. Energy harvesting is when you take something that's happening already and you get energy out of it. So, like the sun shining or you bashing your head against the desk of failure. But seeing as this is Sweden and the sun doesn't exist, I don't have any solar panels. But I do have some piezos, a DC motor with a gearbox, and some stepper motors. I have a bunch more of these. Some of them come from printers, some of them come from photocopiers. I have some 3D printer ones lying around. But yeah, these are the three areas I'm going to focus on, and the circuit itself, the thing you actually need to generate it. And I had a few questions which people didn't answer, so let's get to it. So, first things first, this is the circuit that's required. We have a rectifier which converts AC into DC. So yellow, it doesn't matter which way it goes, indicates no polarity. So anything that comes from any of the devices that I just showed you will be AC. So their output will go into here's input, will go into the rectifier and get converted into positive and negative, which will then go into this tiny capacitor, 16 volt, 470 microfarad, and then I'll be measuring it with my multimeter. So yeah, let's get started with the piezos. All right, starting off with the piezos. This is a tiny piezo element that I think I took out of a greeting card. That they can play music, but they can also be used to make music, seeing as you can find them in electronic drum kits. Normally, there's a resist on the outside of this, but the flexing of the piezo crystals actually generates electricity. So we see it's currently at 0. Let's just give this a few bends and see what happens. And yeah, the voltage is going up. The larger the element, the more it would generate. The whole reason why this exists is just I'm using the pins to jam it in there because the wires are so fine. I actually had much more success on a previous video take where I accidentally said a no word, but I was flexing it quite nicely and it was generating quite a lot of electricity or voltage, I don't know, and the terminal broke off. So probably not the best way to generate electricity, not in the long run. I thought of having something with like undulations on it, and then you could move over this and it would just bend it with undulations. But moving on. Next is this vibration sensor, and it's so tiny, and it's supposed to sense very minuscule motions. So, yeah, wake up, ready, Polly. Yeah, it's pining full of fjords. It doesn't generate anything useful. Next. The final piezo element I'm going to look at is one I took out of a long-nosed fire lighter, those ones that go and then light the flame. I have to admit that this is the whole reason why I actually got such a massive rectifier. It's a 1000 volt rectifier. I also initially purchased huge capacitors because everyone online was busy going on about how high voltage these are. And I thought, well, they generate a plasma. I mean, they burst the air into fire. Thing is, I clearly don't understand how electronics work because that's a 16 volt capacitor, right? So yeah, look at it go. I mean, I guess it doesn't have enough oomph to shove it in the capacitor. I don't understand what I'm doing. But yeah, also clearly not the way to go. Onto the DC motors now. I added a gearbox because I thought, well, if I'm going to buy a DC motor, I might as well get one with the gearbox. It's going to make life so much easier. I'll be generating so many volts in no time. Yeah, as it turns out, this sucks as well. I mean, on the hardest gear, making it spin, you don't get that much. I mean, it's the best one so far, but yeah. Still not that much considering the amount of effort you put in. Sounds familiar. Anyway, stepper motors. The jungle you see before you is necessary, seeing as stepper motors have 2 outputs, seeing as they have 2 phases. So these 4 wires come from the stepper motor, which then go to the 2 different rectifiers, which go into the 2 different capacitors to store the energy. They will store it until I push this button, which then makes connection with whatever load I have on this side. In this case, I have a very tiny resistor just bridging over the two. Initially, when I was reading online, everyone was talking about heat dissipation and, oh my God, you could blow things up. I still have no idea how bad things are, but that tiny resistor does fine, and you don't need a beast like this. I thought I might, but you don't. So yeah, let's see what it can do. This is not a large stepper motor by any means, but if we just give it a quick finger spin, we're already above 5.5 volts. So that's pretty decent. Let's step up our game a little bit. Finally, we have this beast of a stepper motor. It has a fan at the back. I don't know why. It must have been cooling something. I mean, of course. I've only got 2 wires connected up because I can't jam more in it because I don't have the right connector. But there's a second reason as to why I don't have this. Here goes 1 spin. Yeah, that's quite a lot from a single spin. And if I had both hooked up, I probably would blow the capacitors. I don't know, but I guess bad things would happen. Yeah, I mean, that's pretty damn decent. Now, the final thing that I was thinking was, okay, so I have a random value of voltage between something and something. How do I not blow up LEDs? Because I had LEDs as my load. And then when I got something like 10 volts or something like that, well, I'd blow the LED every single time. So let's get onto that next. So when I first started looking into energy harvesting, most people were assuming that there was constantly something coming in. And they just assumed that there would be some battery circuit that could handle converting it to whatever end voltage your load needed. So I bought some buck boost converters. But the thing is, these take so much that these piffly little 470 microfarad capacitors, I mean, you can't even charge them up if these are connected because they're converting to whatever voltage you want. In my case, I'm doing another project, but I need a very specific voltage on this end, let's say 5 volts. So then I was trying to make whatever you generate come in and then come out as exactly 5 volts. And I don't know better, so I figured that was the only way. But then after some searching, I found out that there's a thing called a Zener diode. A Zener diode is pretty much like a normal diode in the fact that it has a very specific direction. On most diodes, they have a little silver line at the end, and that indicates that current can flow that way, but not that way. Zener diodes are pretty much the same. They have a tiny little black mark on them, but the thing is that you're supposed to turn them backwards. So the thing is, it turns out the Zener diodes will block voltage until they reach the voltage that they're limited for, and then we'll let them through. I think that's what I understood. So in order to get, in this case, 3.3 volts going through your load, you take a Zener diode and put it backwards from a normal diode in parallel with your load, and that's how you get it. So in order to stop blowing the LEDs, let's get this. Normally they would kill the LED, but in this case it's just going to go through the Zener diode and generate some heat. So yeah, I finally found what I was looking for. Ha! Suck it, Bono. But yeah, this is going to help me quite a lot in my project. The thing is, you can also take a Zener diode and put it in line with the charging, so that your capacitors will never get above some voltage. So in order to protect my capacitors from exploding, I guess I will put a 16 volt Zener diode in them so that no matter how much you charge, you'll never blow them. You'll probably just blow your Zener diode first. So yeah. Now it's time to shove it inside my next secret project. Bye.